About 252 million years ago, the Earth's biosphere was dealt a devastating blow. Within an extremely short time by geological standards, almost 96% of marine fauna and about 70% of terrestrial vertebrates, as well as about 83% of insects, became extinct. The causes of this catastrophe are still reliably unknown. Whatever they were, the terrible tragedy did not destroy life on our planet. On the contrary, it marked the birth of a new era. Thus began the heyday of the most famous ancient monsters, dinosaurs. The Great Permian Extinction was the milestone that marked the beginning of the Mesozoic era, a new era in Earth's geologic history. It began about 252 million years ago and lasted for about 186 million years. It was a time when our planet was actively changing, gradually taking on its present-day appearance. The most important tectonic process of this epoch was the splitting of the single supercontinent of Pangaea, first into two large landmasses known as Eurasia and Gondwana, and then into the familiar continents. The emergence of many isolated territories separated by seas and straits created conditions for the emergence of independent ecosystems and triggered the development of new evolutionary adaptations. In terms of climate, the Mesozoic was, on average, the warmest era in the history of multicellular life. Throughout the entire period, even in the polar regions, there was no stable ice cover. Nevertheless, temperatures dropped periodically, forcing animal and plant life to adapt to new conditions. The Mesozoic era is divided into three periods, the first of which is called the Triassic. It began about 252 million years ago and lasted about 51 million years. At this time, deep processes in the bowels of the Earth had just begun to break Pangaea into pieces, so that almost the entire period the supercontinent remained whole. In the Triassic, the Ural Range, one of the oldest mountain ranges that have survived to the present day, completed its formation. At that time, these were young and relatively high mountains. The climate of this period was relatively dry and hot, resulting in the formation of many deserts and a decrease in the area of inland bodies of water. For most of the Triassic, the oxygen content of the air was about 10 to 15%, but about 215 million years ago, its level jumped sharply to 19%. The cause of this phenomenon is not known, but it is thought that it may be related to the evolution and distribution of some aquatic or terrestrial plant species. The vast majority of the plant mass at that time was made up of ancient seed ferns, but they gradually began to be replaced by more advanced groups. For example, among them were cycads, ginkgos, and ancient conifers. Many of these groups have survived to the present day, but have lost much of their diversity. Meanwhile, marine life developed in its own way. The oceans that had been emptied after the Permian catastrophe were gradually populated by turtles and bony fish, and the niche of large predators was occupied by the first representatives of the ichthyosaurs, which would later become the most adapted to the aquatic environment reptiles. But in the Triassic, these animals were still quite primitive. One example is Symbospondylus, which lived between 240 and 210 million years ago. This giant sea lizard was 6 to 10 meters long and fed mainly on fish. This impressive beast had a long, narrow body, about half of which was occupied by a flexible tail. It also had a large head and an elongated pointed snout with many small and sharp teeth. The limbs of the Symbospondyle looked like flippers, but most likely it used them only to stabilize its body position in the water. The skeletal structure of the lizard suggests that it swam wave-like, bending its entire body, and was generally quite clumsy. The most characteristic representatives of terrestrial fauna of this time were archosaurs, ancient ancestors of dinosaurs, crocodilomorphs, and birds, as well as many other groups of animals. In the middle of the period, the first dinosaurs evolved from the ancient archosaurs. However, a long and hard struggle for survival was ahead. Only by the end of the Triassic, after a sharp increase in size which coincided in time with the increase in the concentration of oxygen in the atmosphere, dinosaurs began step by step to assert their dominance in the biosphere of the Earth. The images of terrible lizards are familiar to almost every modern person. About them filmed dozens of movies and written thousands of books. At the same time, other, no less important and interesting animals of this period pale against their background. For example, the small animal Oligocyphus, which lived in the late Triassic period, about 200 million years ago. This small and skittish creature belongs to the cynodonts, ancient animals that differed from mammals in only a few subtle ways. Oligocyphus had a slender, flexible body about 50 centimeters long, was covered with fur and looked like a weasel. It was a warm-blooded herbivorous animal, widely distributed on the territory of modern North America, as well as Europe and China. Although it is not known whether Oligocyphus had an abdominal pouch, its skeletal structure suggests that the cubs were extremely small, which is typical of modern marsupials. In addition, it is highly probable that these animals fed their offspring with milk. In addition, it is assumed that Oligocyphus dug burrows and arranged shelters in them, as well as took care of cubs, which may be evidence of relatively high intelligence. Unfortunately, these animals became extinct at the beginning of the Jurassic period, presumably due to a shrinking food base. Nevertheless, they remain the oldest animals that most closely resemble modern mammals. The end of the Triassic period was marked by a massive Triassic-Jurassic extinction. Many species of amphibians, some archosaurs and other reptiles, as well as many groups of plants disappeared from the face of the Earth. Among the possible causes of the catastrophe called volcanic activity, changes in the level of the world's oceans and a sharp change in climate. In any case, this extinction freed up many ecological niches, allowing dinosaurs to strengthen their position on the evolutionary arena of the Earth. The next period of the Mesozoic era is called the Jurassic era. It began about 201 million years ago and ended about 145 million years ago, thus lasting about 56 million years. It was a time of massive tectonic shifts and transformations. It was during the Jurassic period that the supercontinent Pangaea finally split into several land areas separated by shallow seas. If you look at a map of the Earth at that time, by the end of the period, you can already distinguish the outlines of some of the modern continents, although they will be located in completely different places. The isolation of the new continents from each other led to the formation of isolated biosystems, so animals and plants common on one continent could be completely absent from the other. For most of the period, the Earth's climate was hot and humid, but toward the end of the period there was a relatively brief cooling. Huge expanses of land were occupied by tropical forests, consisting mainly of cycads, Holocemus plants, similar in appearance to palms. In addition, coniferous trees resembling modern cypresses and pines were widespread. On land, meanwhile, dinosaurs began to flourish. They showed incredible diversity and occupied most ecological niches, dominating almost every ecological niche. Among them, one could find both small lizards the size of a cat and real giants. In the Jurassic period, the outwardly similar herbivorous dinosaurs, sauropods, which include Brachiosaurus, Brontosaurus, and Diplodocus, as well as other groups, became widespread. The largest of them, titanosaurs, reached a length of 25-30 meters, and their mass could exceed 75 tons. An unusual feature of sauropods was the so-called sacral medulla, an extension at the back of the spine that could hypothetically contain 20 times more nerve tissue than the brain. It is now believed that the sacral cavity was most likely filled with a glycogen body, which was a source of additional nutrition for the giant lizard's nervous system. Meanwhile, other animal groups, such as mammals and reptiles, as well as arthropods, continued to evolve in the shadow of the dinosaurs. In the oceans during this period, bivalves like today's mollusks became widespread, and a variety of aquatic lizards such as ichthyosaurs and plesiosaurs became the dominant predators. If you compare Ichthyosaurus ophthalmosaurus from the mid to late Jurassic period with the older Shavusaurus, it may be hard to believe that these animals are related. The ancestor, Symbospondylus, existed 240–210 million years ago, length 6 to 10 meters, elongated body and head, poorly adapted to aquatic environment. Descendant, Ophthalmosaurus, existed 165–145 million years ago, length up to 6 meters, streamlined body, vertical tail, well adapted to aquatic environment. This aquatic lizard had a dolphin-like body with a graceful and powerful vertical tail in the shape of a crescent moon. It is assumed that he breathed atmospheric air and could spend about 20 minutes underwater, develop speeds of more than 7 kilometers per hour, and dived to a depth of about 600 meters. The structure of the teeth of Ophthalmosaurus allows us to conclude that its main food was mollusks, including squid. Another notable feature of the appearance of this animal were the eyes. Their diameter was about 10 centimeters, and a ring of bone plates protected them from damage. It is assumed that Ophthalmosaurus saw very well in the dark, which allowed it to hunt at great depths, where larger, predatory lizards did not swim. The last period of the Mesozoic era is called the Cretaceous. It began 145 million years ago and lasted about 79 million years, making it the longest phase of the Mesozoic era. Throughout the Cretaceous, the breakup of the continents continued. India broke away from Africa and began a slow movement towards Asia, gradually crossing the Indian Ocean, while South America also broke away and moved westward. As a result, by the end of the period, the shape of Africa, Australia, and Greenland, as well as North and South America, had become similar to the present day, while Europe and Asia were just beginning to find their boundaries. The climate of the Cretaceous period was relatively cool. Between 185 million years ago, the average temperature rose slightly and then began to cool again, which lasted until the end of the era. And it was during this time that Tyrannosaurus and Triceratops, the most famous dinosaurs and true symbols of the Mesozoic, lived. But much more importantly, it was in the Cretaceous period that covered plants, first trees, and then grasses, became widespread. By forming turf, they strengthened the soil, made it more fertile, and the nutritious seeds provided food for many species. This event provided the evolutionary impetus for the increased diversity of mammals and, to a lesser extent, some herbivorous dinosaurs. Therefore, despite the total domination of reptiles in all ecological niches, mammals continued to evolve, their diversity gradually increasing. By the end of the period, it was possible to distinguish separate groups, such as ungulates, insectivores, carnivores, and primates. One of the largest mammals of the Cretaceous period was Repenomamus, which lived about 125 million years ago. Its body length reached 1 meter, and its weight was 12 to 14 kilograms. Outwardly, this creature supposedly resembled the modern Tasmanian devil. Judging by the structure of the teeth, Repenomamus was a predator, but his limbs were short and clumsy, so it is possible that the animal was not afraid of carrion. In addition, there is a curious find: the skeleton of Repenomamus with traces of a small dinosaur in the abdomen. It may be evidence that some mammals of this period may have preyed on small dinosaur species such as Psittacosaurus and Archaeornithoides. Meanwhile, the seas were long dominated by large swimming lizards, ichthyosaurs, plesiosaurs, and mosasaurs. However, about 95 million years ago, their numbers declined significantly as a result of the so-called Cenomanian-Turonian extinction, associated with a sharp decrease in the concentration of oxygen in the ocean. Increased underwater volcanic activity is one possible cause. The end of the Cretaceous was probably the coldest phase of the Mesozoic. All life struggled to adapt to the inevitably decreasing temperature. Dinosaurs were no exception. About 70 million years ago, in the northern part of present-day Alaska, above the Arctic Circle, lived an amazing lizard called Nanooksaurus. Being a distant relative of the monstrous giant T.rex, this dinosaur resembled it in appearance, but had a much more modest size. The length of the body of Nanooksaurus was about 6 meters, and the mass only about a ton, that is, about 8 to 9 times less than the royal Tyrannosaurus. It is assumed that such a reduction in size could be due to a shortage of food. Forced to survive in the harsh conditions of the far north, among snowfields under the cover of polar night, this dinosaur acquired a number of unusual adaptations. First of all, it was probably warm-blooded, and the metabolism of the lizard was characterized by a rather high speed, about the same as that of modern birds. Secondly, it had a multi-layered down and feather cover, which allowed it to keep warm in the bitter northern frosts. This implies that this northern lizard was most likely an active and fast predator. However, in polar night conditions, traditional ways of tracking prey are not so effective, so the Nanooksaurus probably had a well-developed sense of smell and sensitive night vision. These assumptions are supported by the peculiarities of its skull structure. Summers in northern latitudes were short and cool, so the eggs needed an additional influx of heat for normal development of the cubs. It is assumed that nanocasaurs, like many northern dinosaurs, incubated their clutches and also took care of their offspring. The study of the remains shows that this species had a relatively large brain volume, which means that it was potentially as intelligent as most modern birds. Unfortunately, all of these adaptations did not save the nanocasaurus from extinction. About 66 million years ago, the massive Cretaceous Paleogene extinction wiped out all non-avian dinosaurs, marine lizards, and pterosaurs, as well as many other creatures. Nevertheless, the terrible lizards left their important mark on the history of our planet. The ecological niches vacated by them were quickly occupied by birds and mammals, giving rise to a new era, the Cenozoic. Its supreme creation was a unique creature called Homo sapiens, who arbitrarily proclaimed himself king of nature. His journey is still ongoing, and only time will tell where it will lead. Friends, if you have anything to say about it, feel free to leave your opinion in the comments. Your support is very important for us, because creating such releases takes a lot of time and effort. Subscribe to the channel to stay tuned, and give us a thumbs up to get the new exciting video out as soon as possible, and let's hear it.